Polynomial whose highest exponent is 2. So you're going to have that x squared in there. Obviously, an x cubed would be a cubic. So quadratic needs your highest power to be an x squared. In standard form, your quadratic equation is going to look like ax squared plus bx plus c equals 0. So to be in standard form, you must have a 0 on the other side. I also want to note a term that we use a lot is that a right there is called a leading coefficient. That leading coefficient kind of tells you how you want to solve a problem. We'll get into that when we get into the different varieties of solving quadratic formulas. All right, we have a little graph over here, quadratic, but we're going to talk about graphing much later. Today we're going to talk about just solving and setting them up. All right, the most easy ones to solve and the ones that cause most troubles for people are ones that don't have a b or ones that you can take the square root of both sides right off the bat. The problem with this is as soon as we go over the quadratic formula, everyone's going to want to use that for every single problem. And it is. You can use it on every single problem, but it is most of the time not the easiest way to do it. In fact, if we're looking at this one, we have x squared minus 9 equals 0. So to use the quadratic formula, you'd have to put a 0 in for your b term. But then you're doing that whole quadratic formula, making sure you do everything correct, when it's going to be much easier to just move that 9 to the other side and give you x squared equals a positive 9. And now because everything on the left-hand side is squared, you can take the square root of both sides and come up with x equals, well, when you take the square root, you have to do positive and negative. So it results in two answers. So it's going to be positive and negative square root of 9, which is the positive and negative square root of 3. I promise you that's a lot easier than plugging into the quadratic formula or trying to factor it or try to complete the square. Yes?
What's the thing above it? The x squared equals k is included.
Oh, we're going to do that right now.
Oh.
So that was a play on this one, really. So for any real number k, the equation x squared equals k is equivalent to plus or minus the square root of k. It's just saying you could take the square root of both sides. Well, although the next one isn't just regular old x squared, it is just something squared. This is all this is saying. Something squared equaling a number or something. You just take the square root of both sides. This is something squared. So you can take the square root of both sides, and we'd end up with 2x minus 1 equals plus or minus square root of 0, which is just 0. There's no plus or minus 0. It's all 0. Then we'd add 1, divide by 2, and you'd end up with x equals 1/2. ¿Qué pasa?
Is there another answer?
There is not. Well,
because if you like split it.
Yeah.
Okay. Why don't we do that, or is this better?
Well, so x equals 1/2 is the only solution to it. So what I think Mark is talking about is that we can split this, and we could look at this as being 2x minus 1 times 2x minus 1 equals 0. Because if you remember back, and we'll talk about this later on, a squared means there are two zeros. So technically you have to find both zeros. It just turns out 1/2 is both of your zeros.
Except the second one would be x minus 1. Otherwise it'd be 4x squared.
What? Say it again.
No, the 2x minus 1 is squared.
It's squared. This is the definition of squaring something. It's the same thing multiplied twice.
That's not what I was thinking.
So it is
Right.
1/2 with
I see
multiplicity
what
of
it is.
2. Okay.
It's in parentheses.
All right. So whether you meant it to or not, it does lead to a bigger issue that there are two zeros here. It is 1/2 with a multiplicity of 2, but we don't need to know that just yet, so let's forget that happened. Oh, when it happens, it'll be fun when we do it later. All right, our next one. Notice x minus 3 squared plus 8 equals 0. You are not allowed to do this. That is not possible because the entire left side isn't being squared. It is something being squared plus 8. So you'd have to move the 8 to the other side to give you x minus 3 squared. Minus 8 on both sides, we'll have a negative 8. I'm actually going to slide this over a bit because we have a little bit to talk about on this one. All right, we are going to take the square root of both sides now because it's the entire left side. It's a quantity squared, so I can take the square root of the quantity. But here's where you have a problem. We have x minus 3 equals plus or minus the square root of negative 8.
A what?
Oh, it's not real.
It isn't real, but we live in a world post algebra 2, so we have to use I.
To see.
I equals square root of negative 1. So to get rid of a negative, you just put an I in front of it. So rather than thinking about this as being plus or minus square root of negative 8, we're going to think of this as being plus or minus I times the square root of 8. Which we could go further and go, well, that's plus or minus I times, and rather than 8, we're going to put 2 square root of 2. Yeah, I know I have to add the 3 to both sides.
Oh, no, not that.
Oh, okay.
Why do you take the, like, the negative? Like, I know that it goes into I, but why does it go out of the square root?
Why does the I go outside the square root?
Yeah, so it's square root of negative 8, and then I times the square root.
Because, so this is what's happening. In short, if I have negative 8, right? We could rewrite that as square root of negative 1 times square root of 8. That's fine. You're allowed to split it up like that. Well, I actually equals that entire quantity. So we just put I in its place. We're not writing square root of negative 1 all the time. That we know it's an imaginary number, and so we use that to represent it rather than putting a square root of negative 1 over and over.
Just rearrange it in one step.
Yes, we just rearrange it in one step. All right, then continue on. I would have to add 3 to both sides. So we'd have x equals 3 plus or minus. And typically we put the number in front of I. So it looks something like that. There's no hard, fast rule that says the I can't come first. It's just typically you organize it as number I square root. And that is your finished answer. You don't have to separate it. You don't have to show that x equals 3 plus 2i squared root of 2 and 3 minus 2i squared root of 2. That can't be said for this one. This one you will have to write both your answers down because both of them are simplifiable. So in this case, we would take the square root of both sides. And we would end up with x minus 3. I don't need parentheses. Get rid of those guys. X minus 3 equals plus or minus 4. Now when I add 3 to both sides, I don't want this to be your final answer.
Why?
You gotta do both of them.
You got to do both of them. You got to do the 3 plus 4 and the 3 minus 4. So this actually branches off into two possibilities. X equals 3 plus 4. And x equals 3 minus 4. If you leave it in this form, you're telling me to do the math for you. And anytime you tell me to do the math for you, I promise you I will do it wrong. This is going to be 8. This is going to be 103. So we get our points. We're going to say that's 7, and that's negative 1. So if you can simplify, you have to simplify. This one you can't simplify because I have to write the whole thing out twice just with a positive and negative, and there's no further I can go with that. All right, this is the simplest ones to solve, but also the ones that you guys are going to forget about, and it's going to be a hard one on the test because this is the last time we're going to talk about it. Because now we're immediately going to go to the hard ones that require factoring, that require completing a square, and require the quadratic formula. So if it was me, I'd put a little star on here and say make sure you study this before the test. All right, we're going to go on to solving quadratic equations by factoring. That's going to be our first method we talk about. Now, before we get into how we factor, we talk about why we factor. Why we factor is because of something called the zero product property. The zero product property says if I could turn something to a chain of multiplications, and on the other side, it equals 0. So in this case, we have A times B times C equals 0. At least one of those has to be 0. So in this case, either A is 0, B is 0, or C is 0, or any combination. All three of them can be 0, but we know at least one of them needs to be 0. Now when we factor, we get something called factors. Crazy, huh? When you factor something, you get factors. But your factor is something times something equals 0. Well, either your first factor equals 0 or your second factor equals 0. In this case, either x equals 0 or x plus 2 equals 0. Let's us say that, hey, either x equals 0 or it equals -2. Those are our two possible answers. So if we have something already factored and it's equal to 0, that means either our first factor, x plus 3 equals 0, in which case we'd have x equals -3, or our second factor would equal 0. So I'd have x minus 4 equals 0, and then we'll have x equals 4. All right, the first method for factoring, when you have something really, really basic, your leading coefficient's just 1, and you got these small numbers, is to just do trial and error, guess and check. You just are going to try to fill something in, knowing that we're going to have a binomial times a binomial. And we know our first term is x squared, so I'm looking for x times x here. That's why we have that. I know that this last term, when I multiply it together, has to give me -12. But not only when I multiply it together do they have to equal -12, they also have to add together to give me a -1. That's what it says right there. Ross? Sure. -4 and a +3. Let's see. -4 times 3 is a -12. -4 plus 3 is a -1. That's perfect. That works. In this case, we'd have x equals 4 would be a solution, or x equals a -3 is the other solution. So this guess and check, trial and error, works if it's super small, and we can keep track of all the numbers. The problem is they're not all going to be that simple. We might have ones with a 2 out front. That means if I was trying to do this in my head, I don't need you guys to write this down. This is what I'm just thinking in my head. What we'd have to do is we'd have to have 2x times x in our leading term. Now I have to find something that multiplies together to 2, but when I multiply this by this one and this one by this one, they add up to -5. Some people can do that, no problem, but for most of us mortals, we have to come up with a system to solve for that rather than having to keep track of all that at the same time. Now, the only method I teach is factor by grouping. If you use a different method, I'm not going to take any points off. Just make sure you know how to do it and you know the ins and outs of it. Factor by grouping requires you to do 2 columns. We have a AC and B column. I call them the air conditioning and Beyonce column. Our air conditioning column is A times C, but that means you need to know your A, C, and B terms. Your A term is always the one in front of your x squared. The one in front of your x is always your B. That leaves C there. So to do A times C, we would do 2 times 2, which equals 4. My B term always stands alone at that -5. Now, we have A times C. That is your multiplication column. You want to come up with 2 numbers that multiply together to give you 4. So you're thinking 1, 4, 2, and 2. And because it's positive, we could also think -1, -4, -2, -2. So I need 2 things that multiply together to give me 4. However, when added together, they have to make -5. So if we're thinking about -2 times -2, it works for this column because it does equal 4. But -2 plus a -2 equals 4, so that's not going to work. If we try a -1 and a -4, that does equal 4. and negative 1 plus a negative 4 equals 5. Ding, ding, ding. These are our two numbers that we want. We want to use negative 1 and negative 4. Now we go through that process, and the only thing that we need to do with that negative 1 and negative 4 is break apart your b term. That's why we came up with something that negative 1 plus negative 4 equals 5, just so we could break that apart. So it's going to look like this. We're going to have 2x squared, and we're going to break apart that negative 5x into a negative 1x, and we're breaking it apart into a negative 4x plus 2 equals 0. Still the same function, negative 1x plus negative 4x does equal negative 5x, so I just broke it apart. Yes?
Would you have to put the, like a minus a negative 1x? Or no, like, so it would be plus 1x?
No, no.
Is that organized?
No, it is set up how it's supposed to be. It should be, negative 5x should be broken up into a negative 1x and a negative 4x. So if anything, they'll have plus in front of them. But I just, whatever's in front of here, I just drag down with it. Because you have to look at the fact that negative 1x minus 4x can turn back into negative 5x. If you were to turn this into a positive 1x minus 4x would lead you to a negative 3x, which means you changed the problem. All right. Now, the whole point of factoring is turning it into a binomial times a binomial. So breaking this apart turns it into two binomials. We got that guy, and we got that one. Those are two binomials. And what we're going to do is we're going to factor the biggest thing we can out of both of those binomials. So when I have 2x squared minus 1x, well, the biggest thing I can pull out of there is just an x. I can't pull anything out of 2 and 1. So we're going to factor out an x. 2x squared divided by x is just 2x. Negative 1x divided by x is just a negative 1. Now, because our leading term is negative, I am going to pull out a negative. And I have 4x plus 2. The biggest thing I pull out of there is a negative 2. Negative 4x divided by a negative 2 is going to be a positive 2x. 2 divided by a negative 2 is going to be a negative 1 equals 0. The reason why I always teach this method is because you can check to see if you did everything right. If those two things are the same, 99.9% of the time you did everything right. It's hard to do it wrong and to get both those the exact same. Now, since both of those are the exact same, we can now smoosh together that x and that negative 2. 2x minus 1 is going to equal 0. That gives us our two possible answers. We're either x equals 2, or we'll do the whole work on this one. 2x minus 1 equals 0. You would add 1, divide by 2, and you come up with x equals 1. Half is your other one. Now, the reason why we can smoosh these guys together is because if you have 2x plus 3x, you can rewrite it as 5x. But think about what's happening there. So like I said, if you have 2x plus, let's say, 5x, we can say that's 7x. And there's another way we could write that is 2x plus 5x equals 2 plus 5x. The exact same thing's happening here. I have the same thing here, same thing here. So if this would be 2 times 2x minus 1x, and this would be, 5, we could add the 2 and the 5 together. It's just how many you have of something. So you can push these guys together, and we always do that with variables. So it's the same process. All right, the next one. We do have to get that 0 on the other side in order to use factor by grouping. So I have to have 5n squared plus 19n, and we have to have a positive 12 equals 0. Now for my air conditioning column, remember that's A times C. My A value is 5. My C value is 12. So that's going to equal 60. My B value is just 19. So now I need two numbers that multiply together to give me 60, but add together to give me 19. Yeah. 15 and 4. So we have 4 and 15 because 4 plus 15 does equal 19. Remember, the whole reason why we do that is to split apart our middle term. So rather than having 19n, I'm looking at having a positive 4n plus 15n. 4n plus 15n equals 19n, so we're good there. I have 5n squared out front plus 12 equals the big 0. Now I have two binomials. I have that 5n squared plus 4n, and I also have that 15n plus 12. Well, if I have 5n squared plus 4n, the biggest thing I can pull out of there, I can't pull anything out of the 5 or 4, but I can pull out a n out of both of those. So we can rewrite this as n times 5n plus 4. With 15n plus 12, I can't pull an n out because there's not in both of them, but 15 and 12 have a common factor of 3. So we can pull out a 3. 15 divided by 3 is 5n. 12 divided by 3 is 4. I know I more than likely did everything correct because both of those are the exact same. Now I smoosh together my n plus my 3, and we have n plus 3 times 5n plus 4 equals 0. That gives us two possible n values. We could have n equals a negative 3. For this one, I'd have 5n plus 4 equals 0. Subtract 4, divide by 5, and you'll have n equals a negative 4 over 5. All right, we've all factored before. This isn't anything new. It's just maybe we haven't done this method in a long time. Maybe we do the snowflake. Whatever method you do, you've done factoring before. The next thing I'm going to talk about is something that people always just neglect to do. The next thing I'm going to show you is way easier than the quadratic formula on several problems. And that is completing the square. Like I said, I feel like everyone, as soon as you learn the quadratic formula, just plug everything into it. Because it will always work. It is true, it will always work. However, the quadratic formula is like a sledgehammer. It might knock a nail in, but it's going to be difficult, and it's going to be overbearing on some problems. For instance, this one. So if you remember the quadratic formula, we'll talk about it tomorrow, but it's negative b plus or minus the square root of b squared minus 4ac all over 2a. First of all, you have to have that memorized to do that. Well, you don't have to memorize anything for complete the square except for b over 2 squared. It's the only thing you need to know to complete the square. And think about the quadratic formula, how you have to deal with the square roots. A lot of times you have to plug stuff in your calculator. This completing the square problem, when you just have a 1 as your leading coefficient, is going to be as easy as this. First of all, you're going to move that 7 to the other side. So we're going to have x squared plus 6x equals a negative 7. Now, because we're completing the square, we need to add something. So we'll have x squared plus 6x plus something equals a negative 7 plus that same something. Well, that something is b divided by 2 squared. It's the only thing you need to know to complete the square. Our b is 6. So we're going to have 6 divided by 2 squared. This is going to be 6 divided by 2 squared as well. Well, completing the square just means I'm going to carry down that x, and I'm going to carry down whatever's in that parenthesis. So 6 divided by 2 is 3. And that's going to equal 6 divided by 2 is 3. 3 squared is just 9. So this is really negative 7 plus 9, which gives you 2. Well, now I just take the square root of both sides to give us x plus 3 equals plus or minus 2. Subtract 3 on both sides, and we're going to have x equals a negative 3 plus n minus 2. Oh, yeah, square root of 2. Yep. You were 100% right. Nice. There you go. That is my grade book. I just write people's names and random points next to them.
Awesome.
All right, so that's completing the square. Completing the square is ridiculously easy when your first leading coefficient is 1, or it's something, and we'll talk about in just a second, that can divide out nicely and evenly. That's when taking completing the square is really, really easy. Where it becomes more difficult is this problem, because it's going to create fractions. In order to complete the square, your leading coefficient must be 1. It must be 1 to complete the square. It is not 1 here. So to create that 1, you must divide by 2. So we're going to divide by 2, which will make our leading coefficient, leading coefficient 1. All right. So I divide everything by 2. We're going to have x squared minus 3 over 2x. Negative 4 divided by 2 is a negative 2 equals 0. Now we can do the same thing. I move to the 2 to the other side. So it'll be a positive 2 on the other side. And I'm going to do that all in one step. So we'll have x squared minus 3 over 2x plus something. That's going to equal, I added 2 to both sides. So it's going to equal 2 plus that same something. Well, where this gets more difficult is now we're going to have a fraction over 2. So we're going to have a negative 3 over 2 squared. Same thing on the other side. We'll have negative 3 over 2 squared. Well, now when I complete the square, we're going to have x. We bring down our x, and we bring down whatever's inside that parenthesis. Inside that parenthesis is a negative number. It is negative 3 over 2 divided by 2. Keep change flip tells you to do negative 3 over 2 times. The reciprocal of 2 is 1/2, so that's 3 over 2 times 1/2, which becomes 3 over 4 squared. Well, just for the sake of me writing big, and I want a little bit of room to do scratch work, this is also going to be negative 3 over 4 squared. So this is going to be plus negative 3 squared is 9 over 16. So I'm going to rewrite 2 as 32 over 16. So the right-hand side is going to become 41 over 16. Now when I take the square root of both sides, we're going to have x minus 3 over 4 is going to equal plus or minus the square root of 41 over 16. Let's go bloop. We are going to add 3 over 4 to both sides. That'll give me x equals 3 over 4 plus or minus, well, it'll be the square root of 41 over, square root of 16 is just 4. Then we'll have x equals 3 plus or minus the square root of 41 divided by 4. For my money, if I had to choose one, if they said you can use the quadratic formula for everything or you can use complete the square, I would choose complete the square every single time. It works much more efficiently than the quadratic formula, and in fact turns problems like this into a 2-step problem that you can do in your head versus having a whole bunch of b squareds and 4ac's, and if you mess anything up in there, you don't memorize something. This is just b over 2 squared. Is the only thing you need to know for completing the square. All right, so that is your quadratic equation lesson for today. Tomorrow we'll talk about the quadratic formula, which I already told you, so now you know it. Right, we got it all memorized now?
Yep.
Cool.